everybody. In today's class, we'll be covering basics of digital communication and also we'll study a little bit on what is time domain analysis and what is frequency domain analysis. So let's start with some basic concepts of digital communication. So what is analog signal and what is digital signal, just at very high level. In real world, the real world signals are always analog signals, or I should say typically analog signals, say my speech or say temperature measurements. These are all analog signals. Analog signal is usually continuous signals and it's some way to physically you measure it. Digital signals are discrete signals, which is usually generated after some kind of digital modulation. So when we talk about digital communication, the input is always an analog signal which is converted to a digital signal using what we call as ADC, which stands for analog to digital converter. The digital signal is then finally transmitted over different mechanisms that we'll study in future classes, and on the receiver side the digital signal is converted back to analog signal using what we call as DAC, which stand for digital to analog converter, and then we get back the analog signal. So you might ask, why go through all this hassle of converting to digital signal, transmitting it, and then converting it back to analog signal? Why not directly transmit analog signal? The reason is there are various advantages of digital communication. So if you go, some of the key advantages are obviously, since digital signals are discrete, the effect of noise interference is less, it's usually cheaper, it's more flexible, and since you're finally transmitting bits, you typically ones and zeros, binary bits, so you can implement some kind of error correction schemes. You can have coding, some kind of coding to detect the errors and correct those errors. So it's more resistant to noise. You can withstand some noise since you can detect those errors introduced by the noise and recover those errors. And we'll go into details of in future classes. Of course, when you're getting something, there is a disadvantage too. So digital communication, the disadvantage is it requires higher bandwidth than an analog communication. Just to coming back, so this just shows the plot of analog signal. So analog signal is just a continuous signal varying over time. It's not a discrete signal. When you digitize it, you usually have discrete signals. In this case, it's just ones and zeros. You have one, some zeros, one zeros. So you have digital signal is always a discrete signal, and real world measurement is a continuous measurement. So this is very high level of what a digital communication is. Why do you need to go for digital communication? So when we talked about analog to digital converter and digital to analog converter, there are two functional blocks inside those blocks. So on the transmitter side, for analog to digital conversion has two boxes. One is called sampling, and the second one is a functional block, quantization. What's And we'll go into more detail in the subsequent classes, but what a sampler does is it samples the analog. Since analog signal is continuous, the sampling block samples the analog signal in predefined interval, and then each sample is to be digitally encoded. But before that, you quantize that sample, which means you approximate it to a predefined level, and we'll go into detail in next few class. Once you approximate it to a predefined level, then each level is encoded using some kind of binary bit encoder. So, and then the output is your digital signal. So you sample the analog signal in periodic interval. Each sample is approximated to a predefined quantization level. So since you are doing some kind of approximator, it often introduces what we call as quantization error. And then finally, each quantization level is then encoded using a digital encoder, and then the output is a digital signal. Then we do a lot of modulation coding, and then finally it's transmitted. On the receiver side, when you receive this digital signal, there is no desampler or dequantization to reverse this thing. So all you do is you pass through a reconstruction filter on the receiver side, and you can get back the original analog signal. How can a reconstruction filter basically give back the analog signal. We'll again read those things in next few classes, but this is the high level um, uh, representation of what happens in a digital communication. So when you convert from, when I talk about analog digital conversion, I usually talk about sampling, I talk about quantization, and on the receiver side I have this reconstruction filter.